Alright, so the best way to learn how to prove a trig identity is to just go through examples, learn the basic tricks that come into play, and also have your identities sheet handy so that you know how things can be converted from sines to from cosines to secants, tangents to sine and cosine, things like that. So I'm just going to go through some examples, and hopefully as you go through the examples you'll learn some of the tricks and kind of see some of the things that can be done. It's really is trial and error. When they say to prove an identity, there's more than one way to do it. Okay, it just depends on which road you take. Some are longer, some are shorter, but as long as you use concrete algebra, okay, algebra that's valid, okay, and you use identities that are true, your answer will be correct. And our job when we're proving an identity is to show that the left-hand side is actually equal to the right-hand side, to make these two sides look the same. You can do that by changing the left-hand side until it looks like the right-hand side. You can go the other way and change the right-hand side until it looks like the left-hand side of your equation. And sometimes it works best to change the left hand a little and the right hand a little. It really is up to you. When you look at a problem like this where you have secants and cosines mixed, my first step would be to change everything to the same thing, because secants and cosines we know are related. How are they related? Well, secant is equal to 1 over cosine, and cosine is equal to 1 over secant. Now I'm choosing to change the cosine to a secant because notice there's more secants than cosines, so it'd be easier to just change one of them. Well, let's see what happens. So I'm going to work on the right hand side here. I like to keep a little line down the center so I know here's my left side and my right side, and I don't mix them up. Okay, so here we go. I'm going to change cosine here to 1 over secant. So I have secant theta over 1 over secant theta, and here's where your ability to simplify comes in. This is a fraction divided by a fraction, and when we have a fraction divided by a fraction, what do? We invert the second one and we multiply. So this gives me secant theta over 1 times, we invert this bottom fraction, secant theta over 1. Well, what does that give me? Secant times a secant is a secant squared theta over 1 is just secant squared theta. And notice I've simplified that. Have I reached my goal? Does the left side look like the right side? Yeah, and I can just drop this straight down. Okay, some people like to work linear or up and down like this. Others prefer to start with one side and just work side to side. I prefer the up and down method myself. Okay, so I have proven the identity. Now, you can't just write your answer as secant squared theta equals secant squared theta. Your answer is all of this here, where you show why they are equal. So you do have to show your work on these. It's not optional, because that's what your answer is your work. All right, let's take a look at this one. We have cotangent theta plus cotangent alpha. Notice those are two different angles. Divided by tangent theta plus tangent alpha equals cotangent alpha cotangent theta. So again, I have a left side and a right side. Okay. Another tactic is when you have cotangents and tangents, how are they related? There's two different things we could do here. We could change everything over here to sines and cosines and simplify. Or since cotangent and tangent are related, and how are they related? Well, cotangent is 1 over tangent. That's one of our identities. Okay, I am going to use this rather than changing everything to sines and cosines. It will work eventually to change to sines and cosines, but it gets a little messier. Okay, so instead I'm using this. And again, that's where the trial and error comes in. If you've changed everything to sine and cosine, you might get frustrated and try a different way. But it would work in the end if you worked it all the way through. Again, I'm choosing to use this and try this out. Okay, so if cotangent is 1 over tangent, what am I going to do? Okay, well, that would mean I replace my cotangents with 1 over tangents. But then looking at this again, and this is how identities, when you're proving them, this is how it works. You go, okay, is that going to work? What's going to happen? Well, if I change everything to tangents over here, what do I have on my other side? I have cotangents. So I'm going to change my plan. That's part of the job. And instead, I'm going to use the fact that tangent is 1 over cotangent. And I'm going to change everything on this left side to cotangents, because everything on my right side is supposed to end up being all cotangents. And that makes more sense than going the other way. Okay, so that's kind of the trial and error that goes with writing, proving an identity. All right, so here we go. I'm going to replace my tangents with 1 over cotangent. So the top would not change. My numerator would still be cotangent theta plus cotangent alpha. But in the bottom, tangent theta is the same as 1 over cotangent theta, and tangent alpha is the same as 1 over cotangent alpha. Okay, what do I do from here? Well, if this were just an algebra problem, I notice I have a fraction within a fraction, and down here I have two fractions that need to be combined. I would have to get a common denominator. That common denominator would have to include both a cotangent theta and a cotangent alpha. So I'm going to create a common denominator by using multiplication. That's what we do, right? Okay, so here we go. This needs to have a cotangent alpha. Whatever you do to the bottom, you have to do to the top. That's our rule. Over here, cotangent alpha, it needs a cotangent theta. Whatever you do to the bottom, you have to do to the top. Now I have in my numerator cotangent theta plus cotangent alpha over down here, that gives me cotangent alpha plus cotangent theta. I could add them now because they had a common denominator of cotangent alpha, cotangent theta. Okay? All right, it might look a little crazy, but we're getting there. We're getting closer. Because notice we have something the same here. Well, now we have a fraction with a numerator here and a denominator here. Okay? We want to simplify that because notice we kind of have a double fraction going on here. So again, our rule for that is that you invert the denominator and you multiply. So when I do that, I have my numerator of cotangent theta plus cotangent alpha over 1 times the denominator inverted. So we flip that over. That's our rule for dividing fractions, if you remember back. That gives me cotangent theta, cotangent alpha on top now, and cotangent alpha plus cotangent theta in the denominator. Well, notice what happens. Here I have a cotangent theta plus cotangent alpha, and here I have the same. So I can cross cancel, and that leaves me with cotangent alpha, cotangent theta over 1, which is really just cotangent alpha, cotangent theta. Okay, so I started the top, changed everything to cotangents, and then it was just a matter of simplifying my fractions till I come out at the bottom. Notice my left hand side now looks exactly like my right hand side. Everything I used was absolutely legal, and so this would work for proving the identity. I'm going to go ahead and split this down the middle. Again, something we can't do is go from one side to the other. So tools we use to solve equations we cannot use because we're trying to prove they're equal. We don't know they're equal. So we can't use properties of equality like adding to both sides or multiplying by both sides or subtracting from both sides because we haven't shown it to be true that they're equal yet, so we can't use those properties. So we have to either work on one side or the other.
So what I'm going to do, I'm going to work from the left side and think of something cotangent is equal to, it's equal to 1 over tangent. So I'm going to replace both of the cotangents with 1 over tangent. From there, I want to go ahead and get a single fraction on the top and a single fraction on the bottom. So I need a common denominator of tangent for both of them actually, and I can rewrite the number 1 as tangent over tangent, because you can agree that if we reduce tangent over tangent, it's equal to just 1. So now I have on top 1 over tangent theta plus tangent over tangent. And on the bottom I have 1 over tangent minus tangent over tangent. Now that these have common denominators, I can simplify the top and simplify the bottom as a single fraction. So that gives me 1 plus tangent over tangent in the numerator and 1 minus tangent over tangent in the denominator. Our next step is, since this is technically division, we're taking 1 plus tangent over tangent divided by 1 minus tangent over tangent. We're going to go through the process of dividing fractions, which the process is that you invert the bottom. Okay, so we're going to flip this and you multiply. So that gives me, I ran out of room, so that gives me 1 plus tangent theta over tangent, that was my numerator, times, and we have to flip the denominator. And when we do that, my tangents cancel, and I have exactly what I had on this other side, which is 1 plus tangent over 1 minus tangent.